here we shall see few problems on Jacobian. First question comes as if x plus y plus z equals to u and y plus z equals to uv, z equals to uvw, then find the dou of x comma y comma z divided by dou of u comma v comma w. So write the three equations here. These are the three equations. So here x is derivated with respect to u and x is derivated with respect to v, x is derivated with respect to w, and similarly with y with u and v and w, and derivating z with u, v and w. So here the equation should be x should be in terms of u, v and w. Similarly y and z variables also should be in the terms of u, v and w. So we have to make the equations right now. Here the first, let this be the first equation, x plus y plus z equals to u and y plus z equals to uv, then z equals to uvw. So here if you see the z variable, it's already in the form of uvw. So here no need to convert the z now. Then now substitute this z equation in the equation 2. So in the place of z, substitute u, v, w. Then we get the y in terms of u, v and w. So here substitute equation 3 in equation 2. So when you substitute in equation 2, you will get y plus u, v, w equals to uv. Then y is equals to uv minus, when you send this u, v, w to the right hand side, it becomes minus. Then uv, y is equals to uv minus u, v, w. So let this be as equation number 4. Now substitute the equation 4 and equation 3 in equation 1 to get the y in terms of u, v and w. So when you substitute here, x is equals to uv minus uvw plus uvw equals to u. So here x is equals to minus uvw and plus uvw will get cancelled, and send this uv to the right hand side, it becomes minus uv. So x is equals to u minus uv. So let this be as equation number 5. Now we got the x, y and z equations in terms of u, v and w. Now differentiate all these x, y and z variables with respect to u, v and w. So now first take the z equation. Now differentiate this equation with respect to u, v and w. So first we are differentiating with respect to u. That means dou x by dou u equals to dou by dou u of x is u minus uv. So here differentiation of u with respect to u is 1 minus uv differentiation with respect to u is v. So when we are differentiating here, v is treated as constant. So write v as it is, and u differentiation with respect to u is 1. So 1 into v is v. Therefore dou x by dou u is equals to y minus v. Now similarly differentiate x with respect to v. That is dou x by dou v is equals to dou by dou v of u minus uv. Then u differentiation with respect to v is 0, and here uv differentiated with respect to y. Then u is treated as constant. So write u as it is, and v differentiation with respect to v is 1. So here 0 minus u, that equals to minus u. Now similarly differentiate x with respect to w. Dou x by dou w is equals to dou by dou w of u minus uv. So as there is no w variable in this term, then its differentiation becomes 0. So 0 minus 0, that is equals to 0. Now differentiate equation y with respect to u, v and w. So first we are differentiating with respect to u. Our y equation is y is equals to u minus uvw. So here dou y by dou u is equals to dou by dou u of uv minus uvw. So uv is differentiated with respect to u, then v treated as constant. U differentiation with respect to u is 1. So 1 into v is v minus uvw with respect to u. So here other variables, what are the other variables here? V and w are the other variables. So they are treated as constant, write them as it is. Then u differentiation with respect to u is 1. So VW into 1 is VW. Then dou y by dou u is equals to V minus VW. Here similarly, y is differentiated with respect to v, that is dou y by dou v is equals to dou by dou v of uv minus uvw. Uv with respect to v is u, as u is treated as constant and v with v is 1. So now differentiation uvw with respect to v, then u and w is treated as constant, so uw, and v with respect to v is 1. Then y differentiation with respect to w, dou y by dou w is equals to dou w of uv minus uvw. uv with respect to w is 0, as there is no w variable in this term, minus uvw with respect to w is uv is treated as constant, so write uv as it is, and w with differentiation of w with w is 1, so here 0 minus uv, that equals to minus uv. Now differentiate z equation with respect to u, v and w. Then now z with u, that is dou z by dou u is equals to dou by dou u of uvw. Then here vw is treated as constant, so write vw as it is, and differentiation of u with respect to u is 1, so dou z by dou u is equals to vw. Similarly with dou z by dou v is uw, and dou z by dou w is uv. So here the differentiation part is completed. It comes to the determinant, finding determinant, and the formula is here to find dou of x comma y comma z by dou of u comma v comma w, that equals to determinant, that equals to dou x by dou u and dou x by dou v, dou x by dou w, dou y by dou u, dou y by dou v, dou y by dou w, and dou z by dou u, dou z by dou v, dou z by dou w. So the determinant of these all elements gives the final result. Then that equals to, now write the all values whichever we got. So after writing here, now it come to the determinant. So find the determinant here, 1 minus v into u minus uv into uv minus of minus uv into uw, that is here so 1 minus v into u minus uv in uw of uv minus of minus uv into uw, and minus of minus u, that is deleting this row and column, v minus vw into uv minus of minus uv into vw, plus 0 into something is always 0. So now solve this. So here 1 minus v into u into uv is u square v, minus uw into uv is u square vw, and minus into minus is plus, uv into uw is u square vw. So minus u square vw and plus u square vw gets cancelled here. Plus minus into minus plus, u into uv into v is uv square, minus uv into vw is uv square w, minus into minus plus, and uv into vw is uv square w. So these both terms get cancelled. Now here 1 minus v into u square v u square v, that is, and then plus u of uv square, that is here u square v into 1 is u square v, minus u square v into minus v, that is minus u square v square, plus u square v square. So these both terms get cancelled and finally is u square v. So therefore dou of x comma y comma z divided by dou of u comma v comma w is equals to u square v is the final answer. Second question comes as, if x is equals to r cos theta and y is equals to r sin theta, then show that dou of x comma y by dou of r comma theta into dou of r comma theta by dou of x comma y is equals to 1. So we have to prove this condition. So let x is equals to r cos theta be the equation 1 and y is equals to r sin theta be the equation 2. So now differentiate this x equation with respect to r and theta. So first we are differentiating with respect to r, that is dou x by dou r is equals to dou by dou r of r cos theta, that equals to, so when here we are differentiating with respect to r, so cos theta is treated as constant, so write cos theta as it is, and differentiation of r with respect to r is 1. So here you can even use the uv method, but even though you will get the same output, so cos theta into 1 is cos theta. Then dou x by dou theta is equals to dou by dou theta of r cos theta. R cos theta with respect to theta, now r is treated as constant, then derivative of cos theta with respect to theta is minus sin theta. So r into minus sin theta, that equals to minus r sin theta. Now here differentiate equation y with respect to r and theta. So that is dou y by dou r is equals to dou by dou r of r sin theta. Then here sin theta is treated as constant. So sin theta into r derivative with respect to r is 1. So that is sin theta. And dou y by dou theta is equals to dou by dou theta of r sin theta. R sin theta with respect to theta. Then r is treated as constant. So r into sin theta derivative with respect to theta is cos theta. So r into cos theta, that equals to r cos theta. Now the formula comes as here, dou of x comma y by dou of r comma theta is equals to determinant of dou x by dou r, dou x by dou theta, dou y by dou r and dou y by dou theta. So that equals to determinant of, so write all the elements here, that is cos theta minus r sin theta and r cos theta. So here finding the determinant of this, cos theta into r cos theta minus of minus r sin theta into sin theta, that equals to r in cos theta into cos theta is r cos square theta, minus into minus plus r into sin square theta. So if we take r common, we get sin square theta plus cos square theta. Anyhow we know sin square theta plus cos square theta value is 1. So r into 1, that equals to r. So dou of x comma y by dou of r comma theta equals to r. Find out that dou of x comma y by dou of r comma theta. Now we have to find the dou of r comma theta by dou of x comma y. So for that we need some basic calculation here. So equation 1 whole square plus equation 2 whole square. So equation 1 is x into r x is equals to r cos theta, and equation 2 was r in y is equals to r into sin theta. So we have to square them. That is x square plus y square is equals to r square cos square theta plus r square sin square theta. So here first we have the equations x in terms of r and theta. Now we have to get the equations r and theta in terms of x and y. So for that we are doing this calculation, and here x square plus y square is equals to r square of, taking r square common, that is r square of cos square theta plus sin square theta. Then x square plus y square is equals to r square into 1, and that is x square plus y square is equals to r square. So from this r is equals to x square plus y square to the whole to the power of 1 by 2. So we got the one equation which is of r, and that is in terms of x and y. So we can easily derive this now. Now we have to get the theta equation in terms of y and z. So for that we are dividing the equation 2 with respect to 1. So equation 2 by equation 1, that equals to y by x, and that equals to r sin theta by r cos theta. R get cancelled, sin theta by cos theta, that is tan theta, equals to y by x. Then theta is equals to tan inverse of y by x. So let this be as equation number 4. Now we got the theta equation in terms of y and x. Now we have to differentiate it. So now differentiate r with respect to x and y. So first we are derivating with respect to x, that is dou r by dou x, that equals to dou by dou x of r is x square plus y square whole to the power of 1 by 2. Then that equals to, we know that x to the power n differentiation is n into x to the power of n minus 1. So first we have to apply that formula. Then n is here 1 by 2. So 1 by 2 into x square plus y square whole to the power of 1 minus 1 by 2. That gives minus 1 by 2. Then here into, now we have to derive the inside one, that is x square plus y square derivative should be done. Then x square derivative with respect to x is 2x and y square derivative with respect to x is 0. So now we have to calculate this. Here we get 2x divided by 2x, 2, that is 2x by 2 into x square plus y square whole to the power of minus 1 by 2. Then 2 get cancelled, that you get it as x of x square plus y square to the power minus 1 by 2. Now we have to differentiate r with respect to y. So then that you will get dou r by dou y is equals to dou by dou y of x square plus y square whole to the power of 1 by 2. Then that equals to 1 by 2 into x square plus y square whole to the power of minus 1 by 2. So applying the formula x power n, that is n into x to the power of n minus 1. Then into x square plus y square derivative with respect to y. X square with y is 0 and y square with y is 2y. So that equals to 2y by 2 of x square plus y square whole to the power of minus 1 by 2. Then 2 get cancelled, you will get here y of x square plus y square whole to the power of minus 1 by 2. Comes to the differentiation of theta with respect to x and y. So here dou theta by dou x, that equals to dou by dou x of theta was tan inverse of y by x. Now tan inverse of y by x differentiation is 1 plus y by x whole square. So inside term is derivated here. So if it is a tan inverse of x, then differentiation comes as 1 by 1 plus x square. So here x nothing but here this comes as this whole y by x. So 1 by 1 plus y by x whole square. Now inside term also should be derivated here. So y by x differentiation is then here we are derivating with respect to x. So y is treated as constant. So write y as it is, and it is of 1 by x. 1 by x differentiation is minus 1 by x square. Then that equals to 1 by 1 plus y square by x square into minus y by x square. Then that equals to 1 by, taking LCM here, 1 into x square, that is x square plus y square by x square into minus y by x square. Then this x square goes into the numerator and it becomes x square by x square plus y square into minus y by x square. Then x square get cancelled, we'll get minus y by x square plus y square. Then now theta is derivated with respect to y, that is dou theta by dou y is equals to dou by dou y of tan inverse of y by x, that equals to 1 by 1 plus y by x whole square into here 1 by x is treated as constant and derivative of y with respect to y is 1. So that is 1 into 1 by x. Then that equals to 1 by 1 plus y square by x square into 1 by x. Then that equals to 1 by x into x square into 1, that is x square plus y square divided by x square into 1 by x. Then that equals to x square goes into the numerator, it becomes x square by x square plus y square into 1 by x, and 1 x get cancelled, we get x by x square plus y square. Now we have find out the differentiation of theta with respect to x and y, and we have also find out the differentiation of r with respect to x and y. So here it comes to the formula dou of r comma theta by dou of x comma y. That comes as the determinant of dou r by dou x, dou r by dou y, dou theta by dou x and dou theta by dou y. So write all those values in the formula. We get here x of x square plus y square whole to the power of minus 1 by 2, y of x square plus y square whole to the power of minus 1 by 2, and here minus y by x square plus y square and x by x square plus y square. So here when we find the determinant here, x of x square plus y square into minus 1 by 2 whole to the power of minus 1 by 2 is multiplied with x by x square plus y square, and minus y of x square plus y square whole to the power minus 1 by 2 multiplied with minus 5 by x square plus y square. So here x into x is x square and x square plus y square whole to the power of minus 1 by 2. When 1 by x square plus y square, it can also be written as x square plus y square whole to the power of minus 1. and then here minus into minus is plus, y into y is y square, and here x square plus y square whole to the power of minus 1 by 2. Then 1 by x square plus y square can also be written as x square plus y square whole to the power of minus 1. Then here x square of minus 1, when bases are same, powers will be added. So minus 1 by 2 plus of minus 1, that is minus 3 by 2. So x square of x square plus y square whole to the power of minus 3 by 2 plus y square. Similarly here when bases are same, powers will be added. You will get y square of x square plus y square whole to the power of minus 3 by 2. Then here taking x square plus y square whole to the power of minus 3 by 2 common, then you will get x square plus y square. Then here we know that x square plus y square is equals to r square. So write here r square of minus 3 by 2 into r square of, if nothing is there then its power is 1. So here r square of minus 3 by 2 into r square of 1. Furthermore, r power minus 3 into r square. So 2 will get cancelled and it becomes as r power minus 3 into r square. So when bases are same, powers will be added. So minus 3 plus 2 is minus 1. So r to the power of minus 1 nothing but it can also be written as 1 by r. So dou of r comma theta by dou of x comma y is equals to 1 by r. So from first equation we can get as dou of x comma y by dou of r comma theta into dou of r comma theta by dou of x comma y. This was our required to prove, and that equals to, initially we got this value as r into, and now we got this value as 1 by r. So r into 1 by r, so r get cancelled and it will be left with 1. So this was proved, hence proved.